Water on Mars, water on the moon. It seems that there is more water on Mars than we thought, and there may have been more water on the moon in the past, which indicates down deep on the moon, there may as yet be more water than we had anticipated. All this is good news for the future of space exploration and space settlement, which might be good for the ultimate prep of keeping all our eggs out of this one basket, this third rock from the sun. So, my friends, uh, this is most interesting. I'm going to share a screen here and show you a picture of what's believed to be this Mars water. This is a formation found on Mars by the European space agency's Mars Express. Now, this formation is the Medusae Fossae formation. It was actually discovered as a formation, kind of a volcanic formation with a strange low density under here about 15 years ago. Mars Express is the European Space Agency's first planetary mission. And in fact, it's been ongoing for 20 years and is still going strong. My friends, they found this formation, like I said, 15 years ago. What they discovered then was the density was lower, but this is the equator, so they didn't pay a lot of attention to it. They figured it was just like canyons or valleys, rifts that had a lower density dust or maybe volcanic ash in it. But when they came back recently and explored it with the radar called MARSIS, MARSIS, they discovered that indeed this had the characteristics of water ice in it, with some dust mixed in. What's preserved this dust is a layer of dust on top, which is about 400 meters deep. And then this water is underneath that. Now, what you might want to know is in vacuum, liquid water cannot exist. In fact, even ice will sublimate straight from ice to vapor quite often under the right circumstances. It will not go through a liquid transition. It goes from ice to vapor. But that formation of dust on top of it, probably created by the volcanoes that created this very complex here, preserve this water ice at the equator. That's great because that really extends the range of operations that people can easily operate on the surface of Mars should we do so, and there not be other factors that preclude that. So, my friends, this is an amazing find. And in fact, the water in here, if it covered the entire surface of Mars, is thought that it would be like 4.9 to possibly 8.9 feet thick across the entire surface of the planet. That's if it was evenly distributed, of course, and of course water goes downhill. So it all pooled in the southern hemisphere if it were all released, where the elevation is lower, where it may have there may have been an ocean there in Mars's past. That's what is thought. That was a big ocean, the southern hemisphere. So the situation is this is about enough water to fill the Red Sea on Earth. That's quite a bit of water. Mars is a small planet, much smaller than Earth. So, it has only 1/3 of the gravity on Earth. Now, the question is, how well would humans adapt? Could they really live in 1/3 gravity for a long time? Well, the jury's out on that. But definitely, it's a place that humans may operate on. And a lot of people, Elon Musk in particular, have plans for human settlements on Mars. And he's actively pursuing that with his Starship. So this is something that's exciting. The good thing about this is, the best thing about this is for human settlement is the equatorial region of Mars is a lot warmer than the polar regions. Which the equatorial regions is, still pretty cold, but sometimes it gets up to decent temperatures in equatorial regions of Mars. That's the good thing. Decent, but occasionally it might even get up to 70 degrees, but really Mars is kind of like Antarctica for the most part, even close to the equator. So this is really good news for future settlement on Mars, which makes this a primary target area now for some initial settlements. It gives you a lot to work with. Why? Because water is valuable. Water can make air for breathing. Water can help make water for drinking, of course, or growing crops on Mars. It can make rocket fuel, radiation shielding. Of course, the very surface, the regolith or soil on Mars, whatever it is there, also might make a good radiation shield on the moon. That's what we were counting on. 6 feet of it would be enough to block, all manner of radiation you'd ever have to worry about. More on that later in another video. But guys, the thing is that this is extremely useful. Maybe other volatiles in the area too. Then volatiles being the volatiles are the elements that evaporate readily, like carbon, and of course water. It's anything that if you heat it up, it's going to evaporate and go poof and be gone. The moon seems to be very short on volatiles. We'll go into that in a moment. So this is an exciting thing. Now, how it got here is a big question. It probably occurred during some past epoch on Mars when the environment was far different than it is today, like when it was a water-richer atmosphere. Mars does not have much of a magnetosphere today. It's essentially none. In the past, it may have had a better magnetosphere, but not having a magnetosphere has allowed the sun to strip away a lot of its atmosphere, and all that remains today on Mars is an atmosphere that's only 1/100th the density of Earth's atmosphere on the surface, which for all intents and purposes is like a vacuum. It's like being in space. That's the altitude, the kind of density we get at 100,000 feet on Earth. So when you go to 100,000 feet on Earth, you got about the atmosphere you have on Mars. So that's about where our balloons fly. We don't fly aircraft there. The fact that they're flying aircraft on Mars, like the little Mars helicopter, is amazing. Because on Earth, most of our regular helicopters are hard to get to an altitude. So the fact, oh yeah, by the way, they just reestablished contact with the Mars helicopter guys. So this is another thing that they think may have happened, is that some of this might have accumulated due in part to the wandering of Mars's pole over time. Mars doesn't have a moon like we do to stabilize its tilt to the sun. So it varies a little bit more than Earth does. Earth's tilt presently is at 23 degrees. The axis that we spin, from the plane of the sun is tilted 23 degrees. The Martian tilt is currently 25 degrees. Not much different. But it's thought in the past it may have varied from 10 to maybe even up to 60 degrees. So that's also a possibility for how this water got there. Whatever the case is, it's an enormous resource. And I'm going to show you here, guys. This is the Mars Express. As I said, this thing has been in operation for now 20 years. That's amazing. It's still an ongoing mission. And so we're going to talk a little bit now about lunar water, because the moon is much closer to us. NASA's got a program to try to get people back to the moon, eventually build moon bases and maybe settlements there if people can actually live at 1/6G. And that's even a bigger question than 1/3G. So, there may be some long-term physiological reasons that you wouldn't want to be there. Now, we've had people in 0G for a little better than a year. It does have an impact on them. It's hard. And it also affects your tissues, critical tissues in your body, like your heart tissue. So bones, eyes, things like that. So can you live for long on the moon or Mars? We don't know yet. There's concepts for rotating space stations and space habitats, like the O'Neill habitats, which would basically have a biosphere in, kind of like a mini Earth turned inside out, which should provide an adequate environment for people to live in space if it's the case that you cannot handle the lower gravities. So there's a lot of options, and to build those, you could use materials from the moon, in the vicinity of the moon, and maybe even Mars in that vicinity too. So these are exciting prospects. So what happened with the moon is we found a meteorite that had this mineral in it that has a lot of volatiles. Remember, I just spoke about volatiles. Volatiles formed this mineral called apatite. And apatite is in this meteorite, which really stunned a lot of scientists, that suggested that the moon, the lunar environment, once was much more water rich than it is today. That might have been in the soil. The moon has been baked by our sun for a long time. So when the Apollo missions went there, they thought it was just some dry, volatileless, baked body, orb. But later in 2008, they were actually looking at the minerals on Mars, and not the minerals. There's little glass beads on Mars that are formed from all the Mars has got a lot of basically silicon dioxide, what makes sand on Earth. But that stuff has been pummeled hard by meteorites for a long time. And so that stuff gets melted, ejected, and it falls back down as perfect spheres. On Earth, when we have an impact, because we have an atmosphere, they come in as tea kites, which are teardrop shaped. Yeah, we have tea kites, beds of tea kites on Earth from some of our impacts. They're teardrop shaped. On Mars, they're spherical because it's they're falling in zero gravity basically, and they cool off before they hit. They cool off real fast. They make perfect little spheres, and those were brought back from the moon. Good proof that the moon, the lunar missions were real because you don't form spherical objects like that on Earth. So those little glass beads, and I've seen those glass beads myself in lunar samples, and they're real pretty. They're different, all the different little colors. They're real beautiful to look at. But it turns out that those glass beads have water in them too. This believed that was because, again, they have silicon dioxide in there, and the solar wind shoots hydrogen particles out from the sun, and those hydrogen particles impact those glass beads, and when they come in and hit that silicon dioxide, that oxygen in there, they will form some water. And there's a lot more water in those glass beads than what they thought. So the moon, but the moon also has been found to have water in the polar regions. So this is all good news, guys, for space exploration, space development. Here's a paper in Natural Geoscience about solar wind derived water reservoir on the moon, but it's in these glass beads, impact beads. Now, the Chinese lander called the Chang'e 5 confirmed that with the direct return of this stuff. And I don't know why they give that credit when they found it in Apollo samples from before, but they're giving the Chinese credit for that, like everything else. Anyway, well, good for them. Anyway, distribution of water near the poles. Now, what we found started with the Clementine space probe, which was launched, I believe, in 1994. It went to the moon. And the Clementine space probe, I'll show you some more on that in a little bit, was basically a smart pebble strategic defense initiative organization, office development. If you remember, they were going to use smart pebbles to hit warheads in space. That was the plan hatched by Ed Taylor and some of these other guys. Edward Taylor, you might remember, was the father of the hydrogen bomb. So they actually built one of these. You may have seen these smart pebbles flying in a test lab. They could fly like a helicopter and had little divert motors that could fly around. So their idea was using as a kinetic energy impactor based in space, unlike the ones we launched from the ground. Well, that program was never fully instituted, but they did test one on the way to the moon, and they put, I believe it was a mass spectrometer on it looking for hydrogen signs. And they found them in the lunar polar regions, and this was later confirmed by other probes to the moon. So now we know that there's lots of water in the lunar polar regions. So I'll show you some of that here. Your guide, this is from the Planetary Society, your guide to water on the moon. Now, this is talking about those polar regions and some of the other satellites, the Indian satellites and others. Now, on the moon, you've got these permanently shadowed craters. The rims of these craters and moons around these permanently shadowed craters, they're in the polar regions, the North Pole and the South Pole, with the best concentration of this at the South Pole, where we find they got the Shackelford crater. There's more water there than in the North Pole. Well, the cool thing about this, and the reason that a lot of the United States and China probably wants to race to the moon, is because these rims and the mountains that are in sunlight full time are great places to put solar power. Because you can be in the sun 24/7 without having to have batteries to store the solar energy. If you're at the equator on the moon, you got a 14-day night, because the total lunar cycle is 28 days, half day, half night. Well, a 14-day Earth day night is a long time to have to store solar energy. So some people propose that we use nuclear reactors if we go into the polar regions and may still use probably would still use nuclear reactors even here. But the solar power availability is a lot better. Also, these permanently shadowed craters, water-bearing asteroids and comet fragments and things like that impacting over time apparently has left a rich deposit of water in these areas. Now, this is something that's been suspected by proponents of space settlement, space colonization for some time. Gerard K. O'Neill, who wrote the book The High Frontier, The High Frontier, the original book, The High Frontier. General Graham wrote another book called that about space defense later. Same name. I don't know why he put the same name on it, but anyway, both those books are pretty interesting. Especially I like Gerard Kelvin's book. He's the father of the space habitat. Well, not the real father, but he really popularized and developed the concept of rotational space habitats and came up with some of his own designs for that. He's passed away, unfortunately. I did have the pleasure of meeting him once upon a time in Alaska at the University of Fairbanks, Alaska. So he proposed that these craters might have water, and he suggested a mass spectrometer fly there. And here's what we actually found. This is the North Pole. The little blue dots are where we believe water to be. And the South Pole, here's the blue dots where we believe water to be. These dots are indicative of the what we found with the satellites that's been orbiting the moon. And let me come down through here and show you, the Chandra 2 orbiter saw this, the lunar, the LRO orbiter, the lunar orbiter found those things. That was the one that actually gave the confirmation, the LRO. NASA's Viper mission, also did further confirmation of this. So we really want to go back. But what we believe is there's something like, I thought the number was in here, 600, how much is it? 600, let's see it, because talk about how many poles, how much water on the moon, there we go. 600 billion kilograms of water ice on the moon. 600 billion kilograms, enough to fill 240,000 Olympic-sized swimming pools. So the moon has enough water to get us started with space settlement, even there or from there, if you use the O'Neillian concept of using lunar resources with mass drivers slinging it from the surface of the moon to the lunar L2 Lagrange point, which I need to do something on that in the future to explain that a little better. But guys, this could build the space habitats that O'Neill was talking about for rotational habitats in space, or you may have some direct settlements on the moon and later on Mars. So this is very exciting developments. The Clementine space probe was the concept that actually originated from Stuart Nozzette. I'll show a little bit on him in a little bit. Stuart Nozzette ran into some trouble, though, unfortunately. So we had the Lunar Prospector, and we had the L-Cross. All these are things that we're looking at the moon. The Lunar Reconnaissance Orbiter is the one that really did the good confirmation of this water ice. And here's your craters in the South Pole again. That's a little interesting image right there. It gives you some idea. They're really in the shadow there. It's why you don't see them too well. The resolution. And we've wrapped resources on the moon. So where did the ice come from? Yeah, they believe it came from impacts. Yeah, so, we don't have to go talk about why it's important. We know why it's important. So, bang, this is an article on that Clementine itself. That's what Clementine looked like. And I find that one interesting because it was the first one that gave us some indication of that. You can see here's an article on it from Nozzette, Stuart Nozzette. And there is Stuart Nozzette. He was the guy that came up with that concept for the Clementine. But he ran into some trouble. He he was in what looked like a sting operation and got accused of spying for Israel and sending data to Israel. Now, his parents were from Israel, so he got arrested for espionage, and he was under by the FBI. And a lot of people think that was actually a sting operation. They set him up for that. I don't know, but he still fell into it. Well, he actually pled guilty to one charge to basically get him off his back. He did spend a little time in prison, got out in 2020. And that's a shame that he got caught up in all that. I don't know. I guess he did fall susceptible to whatever it is they lured him with, whatever that was. But guys, he was, let me show you something. I met him at a space development conference, the International Space Society, which I chaired one of those conferences myself in '93, the International Space Development Conference. I was a chair of the 1993 International Space Development Conference. At one time, I was the chief executive. I was the chairman of the executive committee, which at that time was the equivalent of being the chief executive officer, the CEO of the National Space Society. Stuart Nozzette got a Space Pioneer Award from the National Space Society. Where's that at? Should be in here somewhere. Personal life, career. It's actually on this site somewhere. I'll tell you. Honors. Here we go. National Space Society's Space Pioneer Award. He got it in 1994. And I want to show you that. Here is the list of all the recipients up through 2020 of the Space Pioneer Award, including YouTuber Isaac Arthur, who's now president of the National Space Society. It includes Michael Griffin, former head of NASA. It includes Peter Diamandis, who started the X Prize. Elon Musk is in here. Paul Allen. A lot of luminaries of the space community. Dan Golden. K. Eric Drexler, who worked mass drivers, who wrote the book Engines of Creation, which was all about what brought nanotechnology to everybody's attention. And in 1998, somebody else won this thing. No, 1997, Mr. Greg Allison. Yeah, how about that? I think I know him. Stop share. There is mine right there. There is my Space Pioneer Award that I won from the National Space Society for space entrepreneurship, because I developed the high altitude liftoff program, HALO, to launch rockets, hybrid rockets that we developed from high altitude balloons. And we spun off a company from that called the High Altitude Research Corporation. We went for the Cat's Prize and many other things. There was a lot of spinoffs from that company. People went in different directions and supported things such as the engine development for Spaceship One and Spaceship Two, which is being flown today by Virgin Galactic. It was developed by Scale Composites under Burt Rutan. So I've got quite a bit of history in that area, and I'll just show you the hybrid rocket motor that was from our Cat's Prize rocket that I used as a tabletop for my laptop. This has been fired. This is what we did test firing on this. This was our test motor. So just to show you how many other YouTubers that talk space actually was involved in both the development of space and also in entrepreneurial sense, and also in the advocacy of space, like in the National Space Society. I was chairman of the policy committee for 10 years, and we played a very instrumental role in opening up the policies that have enabled space privatization, space entrepreneurship, and we have been instrumental in that. So now I've stepped out of the National Space Society because the company I worked for at the time felt like it had the appearance of being a conflict of interest, as we were an advocacy group with the contractor position that I held at NASA at the time. So, but they thought it was looked like it might be a violation of the Hatch Act, but the Hatch Act had nothing to do with contractors. It was really written just for government employees, and that's what the Hatch Act says within the act. But anyway, whatever, when your job's in question, you don't question that, because the National Space Society was an advocacy thing. It wasn't a paid position. I felt like I had more impact in that area than I was having with my day job, but the day job paid my wages. So, you got to go with what puts the bread on the table. So, my friends, I come to you here with the background, the legacy, been there, done that, and I will be doing more videos in the future. I tend to hit things at a higher level so that more people can understand it and appreciate it and know the gravity of it, the importance of these things. I'm not that often going into the nuts and bolts of a lot of these things, which change a lot. I might do it for some historical programs, but we got a lot of things that are changing going down the road, such as Starship. So there are channels that will tell you the nut and bolt changes on every little version. That's fine. It's good. It's interesting. And I congratulate them for doing that. But for me, I think the direction of it is more important. So if you're not subscribed to my channel, subscribe, bang the notification bell, and click all. And that way you can get notifications of my videos. And we'll be doing more here again. I've had a bit of a hiatus in reporting on this channel, but I do plan to pick that back up. So with that, I'm going to say, thank you for watching. Greg out.